Hello everyone, welcome back to Vysh IAS YouTube channel. This is Pooja Sharma and I'm back with the next chapter of this textbook. So before we begin, here are the details of Vysh IAS on the screen. So you can contact on this number for your enrollment details, and if you have any doubts regarding your UPSC preparation, you can also email us and visit our YouTube channel for more such videos. Let's begin. So today we will be reading about water in the atmosphere, the various types, not the various types, the various forms in which water is present in the atmosphere. So first of all, we know that the air contains water droplets or water vapor. So as you can see on the picture also, the water vapor rising upwards, the liquid water turning into water vapor. So it varies from 0 to 4% by volume of the atmosphere, and it plays a very important role in the weather phenomena. Also, there we can see water present in atmosphere in three forms, which is the gaseous, liquid and solid state. So the moisture in the atmosphere, it is derived from various water bodies and through the process of evaporation, and also from plants through the process of transpiration. So thus, there is a continuous exchange of water between the atmosphere, the oceans and the continents through the processes of condensation, precipitation, evaporation and transpiration. So water vapor, it is present in the air. It is known as humidity. The moisture content is known as the humidity. So it is expressed quantitatively in different ways. And the actual amount of water vapor which is present in the atmosphere, it is known as the absolute humidity. So it is the weight of water vapor per unit volume of air, and it is expressed in the terms of grams per cubic meter. So this is just little bit info about how water vapor is calculated and all of that, measured, sorry, not calculated, measured. So the ability of air to hold water vapor, it depends completely upon the temperature. So the absolute humidity differs from place to place on the surface of the earth, and the percentage of moisture content which is present in the atmosphere as compared to the full capacity at a given temperature is known as relative humidity. So with the change in air temperature, what happens? The capacity to retain that moisture, it will start increasing or decreasing, and the relative humidity will also get affected. So it is greater over the oceans and least over the continents, obviously because of the presence of water. So the air containing moisture to its full capacity at a given temperature, it is said to be saturated. And also it means that the air at any given temperature is incapable of holding any additional amount of moisture at that particular stage. So the temperature at which saturation occurs is a given sample of air, which is known as dew point. Next we have evaporation and condensation. So the amount of water vapor in the atmosphere, it is either added or withdrawn due to evaporation and condensation. So what will happen is, if you can see these light blue color stripes of bands, this is the evaporation process, and condensation is when the clouds will form and then precipitation takes place or rainfall. So evaporation is a process by which water will get transferred from liquid to gaseous form. So these two words are very important, liquid and gas, liquid to gas. So heat is the main cause for evaporation. Obviously, when you heat up something only, you see the presence of vapor. So the temperature at which the water will start evaporating is referred to as the latent heat of vaporization. So increase in temperature, it will keep increasing the water absorption and retention capacity of a given parcel of air or a pocket of air. So similarly, what happens if the moisture content is low, the air has a potentiality of absorbing and retaining moisture. So movement of air, it will replace the saturated layer within the with the unsaturated layer which is present, and hence the greater movement of the air, then there will be greater evaporation. Next we have condensation. So what happens is the transformation of water vapor again back to its original form, that is water, is called as condensation. So condensation is caused by loss of heat, the opposite of what happens in evaporation. So when moist air is cooled, it will reach to a level where its capacity to hold water vapor, it will decrease, it will cease. It won't be able to bear that weight anymore, and that's how rainfall occurs. So then the excess water vapor condenses into liquid form, and if it directly condenses into solid form, it is known as sublimation. In free air, condensation results from cooling around very small particles which are termed as hygroscopic condensation nuclei. So if you remember, we have learnt about evaporation and condensation during our school days. So we'll be very well known with some of these concepts and terms. So the particles of dust, smoke and salt from the ocean, they are particularly good nuclei because they absorb water. So condensation also takes place when the moist air will come in contact with a colder object, and it may also take place when the temperature is close to dew point. So we'll learn about this in the upcoming slides. So condensation, therefore, it mainly depends upon the amount of cooling and the relative humidity of the air. So condensation is also influenced by the volume of air, pressure, humidity and temperature, these 4 factors. So condensation mainly takes place when the temperature of air is reduced to dew point with its volume remaining constant. It will be the same, the volume. And then when both the volume and the temperature are reduced together. Then when moisture is added to the air through the process of evaporation. But what happens is the most favorable condition for condensation is when there is this total decrease in air temperature. So after condensation, the water vapor or the moisture in the atmosphere, it will take one of the following forms, either in the form of dew, frost, fog or clouds. So forms of condensations can be classified on the basis of temperature and location. Condensation takes place when the dew point is lower than the freezing point as well as higher than the freezing point. In both the conditions it can take place. So first up we have dew. So when the moisture is deposited in the form of water droplets on cooler surfaces of solid objects rather than the nuclei which will be present in the air above the surface, such as in the form of on stones, glass blades and plant leaf, then it is known as dew. So we can see the presence of small water droplets on leaf like this. So that is only called dew. So the ideal conditions for its formation are clear sky, calm air, high relative humidity and cold and long nights. So the formation of dew, it is necessary that the dew point is above freezing point, as we read earlier in the previous slide. Then we have frost. So frost forms on cold surfaces when the condensation will take place below freezing point, which is 0 degrees Celsius. So the dew point is at or below the freezing point, but the frost takes place below the freezing point. So as you can see over here, these green leaves, the layer of frost on them. So the excess moisture is deposited in the form of minute ice crystals instead of water droplets. So the ideal conditions for the formation of white frost are same as that of the formation of dew, but except one condition, that the air temperature must be at or below the freezing point. So then we have fog and mist. So when the temperature of an air mass containing a large quantity of water vapor, it falls all of a sudden, then the condensation will take place within itself on fine dust particles. It will rest on those dust particles. So the fog is a cloud with its base at a very near to the ground. So we can tell that fog is a very transparent form of a cloud. You can see through it almost, like vaguely. So because of the fog and mist, the visibility becomes poor to 0. So sometimes because of heavy fogs, there will be a lot of accidents which occur. So in urban and industrial centers, smoke provides plenty of nuclei particles, so which will help in the formation of these fog and mist. So such a condition when fog is mixed with smoke, it is described as smog. So the only difference between the mist and the fog is that the mist will contain more moisture than the fog. And in mist, each nuclei contains a thicker layer of moisture. So these mists are very frequent over mountains, as the rising warm air which goes up towards the slopes, it will start meeting the cool air which is at the surface. So fogs are drier than mist, and they are prevalent where warm currents of air come in contact with cold currents. So these, as I said, fogs are like mini clouds in which condensation takes place around nuclei provided by the dust, smoke and the salt particles. So that's what these dust, smoke and salt particles, they will carry these water droplets in the air. So that is how they form. Next up we have the clouds. So a cloud is a mass of minute water droplets or tiny crystals of ice formed by the condensation of water vapor in free air at a considerable elevation or height. So as the clouds are formed at some height over the surface of the earth, they take various types of shapes. So according to their height, expanse is the broadness or the width, density, their weight, and transparency or the opaqueness. Opaqueness is when you can't see the other side, like how a glass will be transparent, opaque is the opposite of it. So clouds are grouped under 4 categories. So first is the cirrus, then we have the cumulus, then we have the stratus and the nimbus. So first up is the cirrus. So cirrus clouds, they are formed at an high altitudes of 8,000 to 12,000 meters, and they look something like this. They are thin and detached clouds having a feathery appearance. So they are always white in color. Next we have the cumulus clouds. So these cumulus clouds, they look like a cotton wool. So as you can see in the picture, and they are generally formed at a height of 4,000 to 7,000 meters. They exist in patches and can be seen scattered here and there. Also they'll have a flat base. Next we have the stratus. As their name only suggests, they are layered clouds which will cover large portions of the sky. So these are the stratus clouds. So these clouds are generally formed either due to loss of heat or the mixing up of air masses with different temperatures. So nimbus is the cloud which is over here. These clouds will be black or dark grey, and they form at middle levels or very near to the surface of the earth. So these are extremely dense and opaque to the rays of the sun. The sun's rays won't penetrate through these clouds. So sometimes the clouds are so low that they seem to touch the ground. And nimbus clouds are shapeless masses of thick vapor. So as you can see in the picture over here, at what height, which clouds are formed. So we just now read about cirrus, we read about cumulus, then we read about stratus and the nimbus. So you can see over here this picture, and these other names which you can see, it is a combination of the other 4. So a combination of these 4 basic types can give rise to the following types of clouds. High clouds is cirrus, cirrostratus, cirrocumulus. Middle clouds will be the altostratus and altocumulus. Then we have the low clouds which are the stratocumulus and nimbostratus. And also clouds with extensive vertical development over here, you can see these are cumulus and cumulonimbus clouds. So you don't have to by heart all of them, but you can just remember the combinations. If you understand the basic 4 properly, then you'll understand the others also very well. So then we have precipitation or rainfall. So the process of continuous condensation in free air helps the condensed particles to grow in size. So when the resistance of the air fails to hold them because of the weight or density against the force of gravity, they'll fall on Earth's surface in the form of different precipitation forms, which you can see in the picture. So after the condensation of water vapor, the release of moisture is known as precipitation. So they may take place in liquid or solid form. So the precipitation in the form of water is called as rainfall. When the temperature is lower than 0 degree Celsius, precipitation takes place in the form of fine flakes of snow, which is called as snowfall, hexagon shape, if you have seen in cartoons and all of that. So moisture is released in the form of hexagonal crystals, and these crystals, they form flakes of snow. So besides rain and snow, other forms of precipitation are also there, like sleet and hail. So though the latter, they are limited in occurrence and they are sporadic in both time and space. So sleet is frozen raindrops and refrozen melted snow water. So when a layer of air with the temperature above the freezing point overlies a sub-freezing layer near the ground, then precipitation takes form of sleet. So raindrops which leave the warmer air encounter the cold air below, because it will be floating at the lower surface, because the warm air will rise towards the sky. So as a result of that, what will happen, they will solidify and reach the ground as small pellets of ice, which will not be bigger than the raindrops from which they are formed. So sometimes drops of rains, after being released by the clouds, they become solidified into small rounded solid pieces of ice, and these when they reach the surface of the earth, they are called as hailstones. So these are formed by the rainwater passing through the colder layers, and these hailstones, they have several concentric layers of ice, one over the other. So now the types of rainfall. So on the basis of origin, rainfall may be classified into three main types, that is the orographic, conventional and the cyclonic or frontal rainfall. So conventional rain is the air which is being heated, it will become light and rise up in conventional currents. So as it rises up, it will start expanding and it will lose all the heat because of the expansion, because the molecules won't be close together when it is expanding. So consequently, condensation takes place and the cumulus clouds are formed. So as you can see over here, then with thunder and lightning, heavy rainfall will take place, and it does not last long for a very long time, and such rain is common in the summer season or in the hotter part of the day. So it is very common in the equatorial regions and also the interior parts of the continents, because interiors will heat up soon, because they'll either be away from the sea and all those reasons. So particularly in the northern hemisphere. Then we have the orographic rain. So when the saturated air mass, it comes across a mountain, it is forced to ascend, and as it rises, it will again start expanding. So the temperature will again fall and the moisture is condensed. So the chief characteristic of this sort of rain is that the windward slopes will receive the greater rainfall. As we saw in the case of Western Ghats and Eastern Ghats, how the windward side will receive a lot of rainfall, but the interior of Western Ghats and Eastern Ghats, or the leeward side, rain shadow area, won't receive rainfall, or it will receive very little rainfall. So after giving rain on the windward side, when these winds reach the other slope, when they take a inverted U-turn like this, then what will happen? Then the capacity to take in the moisture will increase, and hence the leeward side of the slopes will remain rainless and dry. So the area situated on the leeward side, which will get less rainfall, is known as the rain shadow area, and it is also known as relief rain. So then we have the cyclonic or the frontal rainfall. So this type of rainfall, it mainly occurs when the cold air meets the warm air, and since warm air is much lighter, it rises above the cold air. So the rising air is then cooled beyond the saturation point, which will result in heavy rainfall. So these rainfalls will last only for few hours. So now we have the world distribution of rainfall. So different places on the earth's surface, they don't receive the same amount of rainfall. They receive different amounts of rainfall in a year and even in different seasons. So in general, what happens is, as we proceed from the equator towards the pole, rainfall will go decreasing steadily because of the presence of snow. So the coastal areas of the world, they receive greater amounts of rainfall than the interiors of the continents, because when wind is moving across an ocean or a water body, it will drop down more air near the coastal areas, and by the time it reaches to the interiors of the continents, the rain will already get poured away on the way. So very less rainfall will reach to the interior of the continents. So the rainfall is more over the ocean than on the land masses of the world because of the great sources of water. So between the latitudes of 350 and 400 north and south of the equator, the rain will be heavier on the eastern coast and goes on decreasing towards the west. So, but what happens is, between 450 and 650 north and south, why do I feel that this is 35 degree and 40 degree and not 350 and 400? Okay, I just checked in the textbook. Actually, it's 35 degrees Celsius and it's 35 degree N latitude and 40 degree N latitude. I'm very sorry for the mistake. So between the latitudes from 35 degree and 40 degree north and south of the equator, the rain is heavier on the eastern coast and goes on decreasing towards the west. Whereas between 45 degrees and 65 degrees north and south of the equator, due to the westerlies, the rainfall is first received on the western margins of the continents, and also it will go on decreasing towards the east. So wherever mountains run parallel to the coast, the rain is greater on the coastal plain on the windward side, and it decreases towards the leeward side. This is pretty much easy now. So on the basis of the total amount of annual precipitation, major precipitation regimes of the world are identified as follows. So the equatorial belt, the windward slopes of the mountains along the western coast in the cool temperate zone, and also the coastal areas of the monsoon land, they receive a heavy rainfall which is over 200 centimeters per year. Then we have the interior continental areas which receive moderate rainfall of 100 to 200 centimeters per year. Then we have the coastal areas of the continents which will receive a moderate amount of rainfall. Then we have the central parts of the tropical land and the eastern and interior parts of the temperate lands. So they will receive rainfall which is varying between 50 to 100 centimeters per annum. So areas which are lying in the rain shadow zone of the interiors of the continents and at higher latitudes, they will receive very low rainfall which is less than 50 centimeter per annum. Also, seasonal distribution of rainfall, it will provide an important aspect to judge its effectiveness. So in some regions, rainfall is distributed evenly throughout the year, such as the equatorial belt in the western parts of cool temperate regions. So that's all for today. Please make sure to like and share these videos, and also please subscribe to our channel for more such videos on other various subjects. Also leave a one-liner comment, a small feedback or something in the comment section below, and you can contact on this number for any details or doubts or queries. So I'll be back with the next chapter very soon. Until then, all the best and thank you.